The last type of equation that we're looking at in Standard 1 is a rational equation. Now, a rational equation is one where you have variables showing up in the bottom of fractions. Now, this first example does not have any variables showing up in the bottom of these fractions, but we're starting with this example because it's going to help us understand the methodology we should be using. So with this particular equation that we want to solve, the fractions can be kind of a nuisance, right? It would be a much easier equation to solve if we didn't have to deal with that 3 on the bottom, 5 on the bottom, and so on. So one thing that you can do, and you may have done this in solving linear equations in the past, is to clear out your fractions by multiplying by the least common denominator. So we can multiply by the least common denominator, which we usually just abbreviate as LCD. Right? And the least common denominator is the smallest number all denominators are factors of, or the smallest thing that they all fit into evenly or divide into evenly. So in this case, our LCD is 15, right? Because of course 15 goes into itself, but then of course 3 and 5 also both go into 15. And so with that, what I can do is I can say, you know what, I'm going to multiply by 15. But of course I'm going to do that on both the left side and the right side. As long as we do it on both sides, we're fine. And we of course distribute here 15 times x plus 2 over 3. And of course this is going to easily simplify just to 1. And we can do some nice canceling in those terms that we see there. Divide by 3 is 5, divide by 3 is 1, divide by 5 is 3. And then of course we want to do some distributing. So we end up with 5x plus 10. 5x plus 10. And then just be careful here. This is a minus 3, right? So make sure you distribute minus 3 to both of those. So you get minus 3x, and then a negative 3 times a negative 1 is a positive 3. So just be careful if there's a subtraction sign out there. And with that, we've made it so there's no more fractions involved, and this should be a fairly easy equation to finish solving. So 2x is negative 12, which means, of course, that x is negative 6. So what we want to do is keep in mind this method of clearing out the fractions by multiplying by the least common denominator on both sides as we look at rational equations. So here's an example of a rational equation where we have variables showing up in the bottom of the fraction. So our first task is to figure out what the LCD actually is. So if you look back to this one, we noticed that 3 times 5 is 15, right? So the product of those two creates this last one, and so that made it really easy to see that 15 would be the least common denominator. Now, in order to be able to see whether that might be the case here, it's important that we always factor every denominator if it isn't already. We need to do that before we decide what we think that least common denominator actually ought to be. So if we factor each denominator, and 2 of them here, the ones on the left, don't require any factoring. right? But over here, we do need to factor this. And remember, when the middle term is missing here, then this is a difference of squares. So x plus 2 times x minus 2 gives us x squared minus 4. And so what I can see here is that, okay, well, x plus 2 divides evenly into this, x minus 2 does as well. So my LCD is x minus 2 times x plus 2. If you don't factor all of the denominators, what's liable to happen is that you can end up with a least common denominator that's not actually the least common denominator, and then your whole equation blows up into something that is pretty ugly. So make sure that you take care to do that. All right, and then of course we can multiply by that LCD that we just found. And so when I do this, right, these problems can tend to be a lot of writing when the least common denominators kind of got a lot to it. I encourage you not to skip steps though. Just carefully go through, do the steps so that you don't drop signs, drop variables and things like that. All right, so over here I know I need to do some distribution, right? And I'm not going to be in a big hurry to cancel anything out. I'm just going to write out what it is. It's x plus 2 times x minus 2 times x plus 5, all divided by x minus 2, and then 5 times x plus 2 times x minus 2 all over x plus 2 is equal to, now this one there's only a single term on the right side, so I feel pretty comfortable going ahead and doing my canceling right now since there's just a single term. So all of that cancels out, so I'm left with just a 28 on the right side. Okay, and then I can easily see what cancels in those terms on the left side. So I have an x minus 2 canceling here and x plus 2's canceling right there. So just to clean up where we're at, we've got x plus 2 times x plus 5 minus 5 times x minus 2 equal to 28. And last time, if I go back to that previous question real quick, so what did we do? We had our 5 out here and we distributed, right? We had our minus 3 out here and we distributed so that I can try to get my x's together. We want to do the same thing here. We want to multiply everything out so that we can combine like terms. So of course this is a job for foiling. So first, outside plus inside is plus 7x plus 10. And then remember, I'm taking this minus 5 through to both of these. So minus 5x, but then plus 10, right? Negative 5 times negative 2. And so combining like terms, we get x squared plus 2x plus 20 equals 28. Now I have a quadratic, and this might happen. You might have quadratics pop out as the equation you need to solve after clearing your fractions. So in a situation with a quadratic, we want to typically get one side equal to 0, so we'll go ahead and take 28 away from both sides. So x squared plus 2x minus 8 equals 0. And that looks like something that can factor without too much trouble. So I'm kind of thinking x and x. 2 times 4 gives me 8. So how about plus 4 minus 2? 4x plus negative 2x is positive 2x. So this tells me x plus 4 equals 0, so x equals negative 4. This one tells me that x must be 2. Now before we circle our answer and move on, there is one last step, and you should maybe pause the video here and think for a moment about why I might not quite be ready to be finished yet. the issue here is that I only want one of these solutions. I do not want this one. You remember that this happened with radical equations, where you might get potential solutions that actually don't work out in reality. Because remember that in order for something to be a solution to an equation, it has to make the left side equal the right side. This x equals 2, if you look up here and here, if you plug x equals 2 in for x in either of those denominators, it makes the denominator 0. And we know that we're never allowed to divide by 0. So it is not a solution. All right, x equals -4 is not going to cause me to divide by 0 in any of those, so that one is my solution. So it's important, you don't have to take a long time and necessarily plug it back into everything and make sure the left equals the right. You don't necessarily have to go that far, but you have to look back and say, do my potential solutions cause me to divide by 0? And it's a lot like the same sort of reason that we got fake solutions with radicals. Up here, clearly x equals 2 couldn't be a solution. But when you multiply through by these factors here, well, this factor becomes 0 when x is equal to 2. And so if you take something that's, untrue, like 4 equals 3, and then you multiply by 0 on both sides, what do you get? You get something that's true. So that's what's happening here. Something untrue doesn't work, then then you multiply by 0. Well, that kind of just zaps everything, and so you get this kind of fake solution that pops out the other side. All right, so here's another example, and this one just shows kind of a more challenging setup where we've got to be really careful with our factorization. So we know that we got to factor everything completely first. So if I look at that first fraction, no factoring I need to do in that denominator. But then as I move on to this one, let's not forget about just the easy type of factoring where you pull a common factor out from both terms. And I can see I can do the same thing here as well, right? I can pull a 2 out here. So I've done all this factoring, but then if I take a look at this, this can be factored, right? That's a difference of squares. So before I'm ready to find my LCD, I have to take one more step and factor that even more. Now, I just want to make a little note here that if I wanted to, I could cancel out the 6 and the 3 to just put a 2 on top, and I could cancel out the 70 and the 2 to get rid of this 2 down here. So I could absolutely do that, and I normally would because it makes the problem easier. But I'm just going to sweep that under the rug for a second just to show something that you may have to do in the midst of the problems you're solving. And that is account for variables and numbers at the same time when finding your LCD. So the way to approach something like this is if you have numbers and variables, just take it one at a time. So if you're seeing this 3 and this 2, just think to yourself, okay, if I had 1/3 and 1/2, what would be my least common denominator? Well, 6 is the smallest thing they both fit into, right? So you would go ahead and put a 6 here. And then you look at what's left here. You have x plus 1, x minus 1. X plus 1 fits in there. X minus 1 divides into that. So it must be x plus 1, x minus 1. Again, Technically could have done some canceling to avoid that, but I wanted to at least illustrate how that worked. All right, so then I can multiply through by all this stuff. So we have 6 x plus 1 times x minus 1. I'm multiplying that by this left side. Lots of writing here. All right, and like on my other problems, I need to do some distributing through here. So I have 6 times 4 is 24, x plus 1, x minus 1, over x minus 1. And then 6 times 6 is 36, x plus 1, x minus 1. And then over here, I think I can go ahead and do some canceling right off the bat. So, I can cancel here, make that a 3, but then I can also cancel there and there. So 70 times 3 gives me 210. And then again, we can cancel on the left side with those terms. So my x minus 1's cancel, my x plus 1's cancel, and 3 goes into 36. So what I'm left with here is 24 times x plus 1 and plus 12 times x minus 1 equals 210. 24x plus 24 plus 12x minus 12 equals 210. And putting my like terms together gives me 36x plus 12 equals 210. So 36x equals 198. And then just divide by 36 on both sides. So let's see here, 36 goes into 198. Do we get a nice number here? Get 5.5. 5.5. And remember, all I have to do is just make sure that 5.5 doesn't cause me to divide by 0 in any of these fractions, and it does not, so we're good to go there. One last example. So here we have a rational equation. Sorry, I had trouble spitting that out. A rational equation with two different denominators that really can't be factored, right? So one thing I want to point out here is even though you might look at this and say, well, they both have t's in them, you need to regard these types of denominators as completely different from one another, right? Pretend like they have no factors in common. To understand why, think of it like this. If I plugged the number 23 in for t, then this would become a denominator of 3. And this one would be a denominator of 23. 3 and 23 have no common factors, right? And so if two numbers have no common factors, just like 3 and 5 have no common factors, then you find their LCD by multiplying them together. So it's no different here. Our LCD is going to be simply t times t minus 20. So that's what I'm going to multiply by on the left and on the right. So over here, nothing to cancel, so I want, maybe I'll put that 4 next to the t. Here, I'll distribute through 480 t times t minus 20 over t minus 20, 480 t times t minus 20 over t. And on the right side, we do get some nice canceling. So my t minus 20s are gone here, my t's are gone here. And so now it's just a bunch of distributing that I need to do. So on the left side, I end up with a quadratic over there. So here I have 4t squared minus 80t. And 480t is what's left here. And then I've got to distribute negative 480 through to both of those, right? So it's going to be minus 480t. And then we have 480 times 20, so that's going to be plus 9,600. So it's kind of nice, these two zap, right? And then moving this to the other side, I have 4t squared minus 80t minus 9,600 equals 0. Now, first of all, now this gives us a chance to just kind of review what we're doing whenever we see quadratics. So when I have a quadratic, if I notice that I can factor a common factor out of all the terms, I want to do that. And I want to do that regardless of whether I'm trying to solve by factoring or solve using the quadratic formula. Because even with the quadratic formula, it's nice to put smaller numbers in. So I'm noticing I can definitely take 4 out of there. And let's see here, 96, so that's going to be 2,400. And then, of course, you can divide by 4. All right, so this becomes t squared minus 20t minus 2,400. Now, this very well may still factor. However, I'm looking at this and thinking, you know what, I might be at it a while if I'm trying to factor this, so I'm going to go ahead and just use the quadratic formula regardless. So I've got it all set up. So t is, right, a equals 1, b equals negative 20, and c equals negative 2,400. So we have the opposite of negative 20 plus or minus the square root of negative 20 squared minus 4 times a times c. All divided by 2a. So t is 20 plus or minus the square root of, so we've got negative 20 squared is 400. And then here we are going to get plus 9,600 all over 2. And those go together to make 10,000, which is nice because 10,000 is a perfect square. So t is equal to 20 plus or minus 100 over 2, which gives me two different answers. T could be 20 plus 100 over 2, which is 60. And t could be 20 minus 100 over 2, which is negative 40. Neither one of those makes me divide by 0, so both of these are solutions to mine.